Okay, so hi everyone. We will have another video in number theory, and there's one additional. For the linear Diophantine equations, there's a lot of comments that is asking me to do more examples. So let's do more. This will be in particular solution. For example, how do we solve the LDE? That's the linear Diophantine equation, given in this form. So we have 7x minus 9y equals 3. So what I'm doing here, actually, what I'm using is my cell phone right now. I'm checking this app, and then I'm checking this new stylus that I have. And let's see if it will work on this video, and then let's have it. First, we need to remember a theorem that will help us in answering this question. Solve the linear infinite equation 7x plus rather minus y equals 3. So we have this theorem 3.10 that we should think about, and we should understand the statement of the theorem. So theorem 3.10, in some books it may be called like different in a different name, but in our book we'll call it theorem 3.10. The LDE ax plus by equals c is said to be solvable. Let's emphasize that. Okay, so this LDE ax plus by equals c is said to be solvable if and only if you have a certain d which is a factor of c, wherein you can say that d divides c, in other words, where your d is defined as the greatest common divisor of the two coefficients of your variables x and y. So you have a and b. So whatever is the GCD of your coefficients, make sure that it is a factor of your right-hand side, which is your c, and then you can therefore say that the theorem, or rather the equation given, is solvable, and it is a Diophantine equation for sure. Now, the next statement of the theorem is that if you have a certain, say you have a certain x sub 0, sorry, that's an x sub 0, and a y sub 0, which is a particular solution of a given LDE. Therefore, all the solutions are given in this form. Okay, so we have all your x's. Let this be x sub n. So for all the t's that we have, so your x's are defined as the first value that you have plus b over d. This is your coefficient of your y divided by the d, the GCD of the coefficients, and times this t, where your t is in terms of all integers. Likewise, to get the values of all the y's that you have, get which is this, you have the y sub 0, which is the particular solution that you got, minus the coefficient of the x divided by the GCD of the coefficients multiplied by t. So that's what we want to think and what we want to use in this video, and then we're going to make use of this, and then we'll find the general solution, all the solutions of the example that we have been given here. So let's try to find it. First, we need to make sure that this is solvable. Okay, first things first, make sure that this LDE is solvable itself. So the formula, or the way to determine that, is we need to get the value of d first. Remember that your d is the coefficients, rather the GCD of the coefficients of x and y. So let's write here solution. Okay, so we need to get first the GCD. So we determine the d, our d value, which is equal to the GCD of a and b. Well, we need to remember that this is in the form of ax minus by equals c. So you have your a here, which is 7, b here as negative 9. So we have 7 and negative 9. Doesn't matter, it can be positive 9. So the greatest common factor between the two, what would that be? So you can just get it, make use of the Euclidean algorithm, but it doesn't, we don't need to do that. This will be equal to, what do you think? What's their GCD? Okay, so one thing you can see here is that 7 is a prime number actually. So we have a remark or a theorem maybe that whenever you find the GCD of of any two numbers, and one of them, any one of them, at least one of them, is a prime number. So therefore, they should be relatively prime. So therefore, the GCD of D is going to be 1, which makes things easier for us, because 1 is a factor of all numbers. So it's like a universal factor. So clearly, we can say that 1 divides 3. So we can therefore say that, well, clearly 1 where D divides 3, which is our C. Hence, this LDE is solvable. Now, if it is solvable, we can move on to the next part, wherein we are going to make use of this information here, which is these x and y. So in order for us to get all the solutions of that problem, so we should obtain all the integer solutions of this problem. So let's make it bigger. And we can see, making use of this information here, so we can get all the general formula, the general solution of our x is going to be x sub 0. First, we need to understand and we need to find one particular solution of x and y. So what multiples of 7? Deduct that by a multiple of 9. And what you'll have is a positive 3. Okay? So one thing you can find of, and by inspection and by trial and error, you can get 7 as 3. So you multiply 7 by 3. So that's going to give us, sorry, that looks like a 5. That's going to give you 21. Sorry about that. That's gonna give you a 21. Okay, and then you're gonna substitute y to be 2. So 21 minus 18, that's 9 times 2, is gonna give you 3. So that's one particular solution. So we're gonna set that as our x sub 0, which is going to be 3, and then our y sub 0, which is going to be 2, positive 2. So we have 3 and 2. So to get all of the possible, the general formula, in fact, of x, we need to put all x sub 0 plus b over d times t. So whatever t is. So some books would like to call it as k actually, instead of t. So anyways, what is the general formula for the x? So what we have is x is going to be equal to the particular solution that we got, which is equal to 3. Okay, plus we have b over d. So our b is clearly minus 9 over d. So d is 1. So instead of plus, instead we're gonna write minus 9 here. Minus 9. And then that's gonna be multiplied by t. Okay, so we have all our x's in the form of 3 minus 9t. Okay. Next up is our y values. So our y, sorry, that's a t. Our y is going to be our first solution for the y sub 0. That's 2. Minus our a is positive. So that's going to give us, our a is positive, though it's y minus this. So we're going to make it negative. So 2 minus 7 over 1. So that's going to give us 7. And then multiply that by t. Sorry, the space is quite not enough. So let's try to fit it. 7t. Okay, so these are our solutions. So our general solution for the x is x equals 3 minus 9t, and for y we have 2 minus 7t. Okay, now you may want to check and you try to try to input positive 1. Say t is 1. So say t equals 1. So just try to imagine it. I think we have no more space. Yeah, we do have something here. So for example, if your t is equal to 1, so your x would be like well, this is 1. This is gonna give us minus 6. And your y would be that's gonna give you minus 5. And that's for sure one solution of the problem. So try to input. So we have, just to check, so we have 7 times negative 6 minus, that's going to give us 9 times negative 5. It should be equal to 3 though. Negative 9. Negative 9 times negative 5. Okay, so it should be equal to negative 3. So we have this is going to become negative, so 42. This is going to become positive 45. So clearly you can see that the answer is positive 3, which makes it clear that this is a general solution. So if you want to check more, you can. But by the theorem 3.10, it guarantees that all of the solutions will be in that form. Okay, so that's one example. I'm going to provide more examples of this as requested. Kind of wait for my other videos, and for sure I'm going to provide more examples. So you can take a picture of this if you want to get the whole picture. Okay, so thank you very much for that. Thanks for watching. I hope to see you soon. I'll be uploading more videos, and thank you very much. Okay.